In the last video, we learned about the DFS graphs, and in this video, we are going to learn about linear search algorithm. So let's begin by first understanding what is searching. It is the process of finding some particular element in the list. If element is present in the list, then the process will be successful, else unsuccessful. If the process is successful, it returns location of that element. We have two popular methods for searching in data structure. They are linear search and binary search. In this video, we will learn about linear search. It is simplest searching algorithm and also called as sequential search algorithm. The list is traversed completely. It means we search the list to match the element whose location is to be found. Then the location of the item is returned. Otherwise, the algorithm returns null. It is usually used to search the element from the unsorted list. That is the list in which the elements are not sorted. The worst case time complexity of linear search is big O of n. To understand the working of the linear search algorithm, let's take an unsorted array. It will be easy to understand the working of linear search with an example. Here I am taking the example of an unsorted array of numbers having n is equal to 8 elements and index value is equal to 7. Element to be searched is 41. There are two possibilities in this searching. Either the element is present in the array or not present. If the element is present, it will return the location of that element. Say for example, here we are searching for the element 41 and the index value of the given element is 5 and position is 6. Don't get confused. Index and position are two different things. Index value starts its count from 0. You already know it from array. If the element is not found in the array, then the program should print as element not found. Let's see the working of the linear search. In this search, the searching begins from the starting of the array, that is from the 0th index. We are going to compare each element of the array one by one until we find the match. We will stop searching only if two possible cases. The first one is when we find the element or we reach the end of the array. In the case we don't find the element. See here, the first element is 14 and it is not the element that we are looking for. So move to the next element. Next element is 4 and the match is not found. So move to the next element. The next element in the array is 19. It is not the element we are searching for. Therefore, move to the next element. And the next element in the array is 34. This is also not element we are looking for. And the next element is 1. This is also not the element we are searching for. So move to the next element. And here we found the element that we were searching for. That is 41. Now, how do you write the code for this? You can write in two ways. Either using iterative method, that using for loop, or write down a function for a linear search and call that function in a main program. We are going for iterative method. So we are going to start our loop from the 0th index and loop will continue searching till the end of the array. So the for loop will be like this. For I is equal to 0, I is less than n, I plus plus. For finding the element, we will write the if condition. Open brace. If a of I is equal to data, here the data element is the element that we are searching for. When we find the element, we will have to print it with this statement. Printf element found at index %d of I. Close brace. Close the printf here. Close the if condition. Let's see how the code is traced with the searching element 41. Here the first index value is I is equal to 0 and less than n. We will enter the if condition. A of I is not equal to data. That is 14 is not equal to 41. The control will not go to the print statement because we have not found the element. It will be moved to the print only after we find the element. So the next is I is equal to 1 and A of I is not equal to data, that is 4 is not equal to 41. Next I is equal to 2. A of I is not equal to data, that is 19 is not equal to 41. Next I is equal to 3. A of I is not equal to data, that is 34 is not equal to 41. Next I is equal to 4. A of I is not equal to data, that is 1 is not equal to 41. Next I is equal to 5. A of I here it is equal to data. 41 is equal to 41. Now the control will move to the next statement and print element found at index 5. But here code won't stop. It will search further till the end of array. Next I is equal to 6. I is less than n. So A of I is not equal to data. That is 66 is not equal to 41. Next is I is equal to 7. I is less than n. A of I is not equal to data. That is 16 is not equal to 41. Next is I is equal to 8. But here I is not less than n. So the loop will end and print the statement element found at index 5. We have found the element at index 5 itself, but our code did not stop there. It went on further searching for the element till the end of the array. It is because we are not stopping the for loop condition when we find the element. So to stop it, we have to write one more condition, that is break. It will break the loop. So far we saw the first condition when the element was present in the array. So next we will see the second condition when the element is not present in the array. Suppose if you are searching the element that is not present in the array, then you have to print the statement as element not found. Let's see how to write code for that. See, if the element is not present, say for example if we are searching for data 21 and 21 is not present, when code reaches I is equal to 7, 7 is less than n, so it will go to the if condition, checks for the data, and here 16 is not equal to 41, it goes back to the for loop. When I is equal to 8 and 8 is not less than n, so controller will come out of the loop. Then it will print this statement element not found. So for this we will write the code as if I is equal to n, printf element not found. This is just the logic of the program, not complete program. To execute the program we have to write complete code. You will get the complete code in our DSA application. You can install it from Google Play Store or you can also install it from the link given in the description below. Now let's see the time complexity for the linear search algorithm. Best case is when you find the element in the very beginning of the array. That is, if the data is equal to 14, so the complexity will be big O of 1. That is, we will be doing only one comparison and we will find the element that we are looking for. Average case is equal to the sum of all cases divided by the number of cases. If the element is present in the first index, then 1. If the element is present in the second index, then 2. That is 1 plus 2. For third, 1 plus 2 plus 3 and so on. And it is divided by the number of cases and it is divided by n. Therefore, the time complexity will be big O of n. Worst case would be when you search the element 16 in the array, because it should go on searching till the end of the array to find the element, as 16 is in the last element in our array. There will be n number of comparisons, so the time complexity is big O of n. Please like the video, subscribe to our channel, and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below. And thank you for watching.